Hello, good afternoon. So today I will to make the presentation about the deep renovation activities using the shallow geothermal energy for exciting residential buildings. As we all know, buildings are the EU most important energy consumer. They cost 40% of EU 27 for energy consumption in 2019. More than 220 million building units, representing 85% of EU building stock, were built before 2020. 85 to 95% of existing residential building will still be in service by 2014. However, only 1% of existing buildings undergo any saving renovation every year in the EU. The deep renovations are discouraging energy consumption by at least 68% are conducted only in 0.2% of existing buildings per year, according to the EU2. Otherwise, it will be become unlike that EU will be able to reduce emission in line with 1.5 thresholds of the Paris Agreement. This is shows that the target share of the energy from renewable sources in the EU member states. From this picture, we can to know that the Netherlands is maybe a low rate compared with other European countries. The target by the EU in 2018 was to have up to 32% of total energy from renewable sources in all the member state countries by 2013. Unfortunately, the Netherlands has not attained its share. In 2017, the Netherlands brought 6.6% of its total energy from renewable energy sources. The target at that time was 14%, so the Netherlands failed to meet it. The share of the renewable energy for heating and cooling is relatively low in the Netherlands. Unlike the other renewable energy technologies, geothermal energy is available around the clock, even through the years. At a certain depth, besides geothermal energy can continually and reliably supply energy anywhere. This, therefore, is a good choice for promote deep renovation of these exciting buildings. This is about the uh, European Geothermal Energy Council 2021. About 2.1 million geothermal heat pump systems were operating in Europe, representing an estate capability around 27 GWT and up to 7 million of geothermal heating and cooling. Sweden and Germany has a good practice with accounting for about half of these skills. Uh, this is about the map of geothermal district heating and cooling in Europe, and the right picture is about geothermal district heating from the 2010 to 2020. And another picture is about the number of geothermal district heating and cooling operation in development. And so the last picture is about the geothermal heat pump inside Europe. Most of the EU member states failed to achieve their geothermal heat pump objectives. This result also reflects the relevance of geothermal energy and though to meet large energy needs and potential for a rapid scale up with the right policy are in place. This is about the geothermal heat pump system and its integration with buildings. From this picture, we can to see a lot of the types of the geothermal energy. The types of geothermal energy, shallow geothermal can be selected according to household demands and local geographical condition process. Uh, from the picture, we can to know that the just shallow geothermal energy can be divided into the vertical uh, Cisco and lobster collector and horizon collector. Uh, and we based on the practical applications, we can to know the vertical collector is the most common used in practice. This was an example of the single self-building home. This example is based on the cost of a vertical geothermal heat pump borehole project for one building. I need less space than other types, but the borehole are most costly due to the specific draining equipment needed. If during the service life, the GHB system has a relatively low running cost and could reduce 20 tons of CO2 emissions. It also shows that operation incentive measures are necessary from the local government to promote these technologies. This is both a geothermal ventilation system and integration with energy storage. This is a special shallow geothermal energy systems. Uh, Compared with horizon, horizontal geothermal ventilation, the vertical systems has some of the advantages. For example, the less land occupation and easily resolved concentration issues and high heat exchange efficiency. This is about the models, time-to-time dynamical integrated models of a carbon system for building heating and cooling. This is about the operational performance of systems. For one well, the depth of 16.5 meters and the damage of 219 millimeters is considered. The annual payback time is 8.2 years, and the total CO2 emissions mitigation potential of system is 7,170 pounds 57 kilometer during the life cycle. Uh, from here, we get to know it is excellent some performance, but relatively high internal investment cost. This is about the potential barriers to promote geothermal heating cooling for exact buildings. From the technical perspective, we can to know that it's a lot of the barriers, for example, unified soil preparedness results into high uncertainty in design. Unreasonable design lead to high construction costs. Unreasonable structures lead to high operation costs and lack of dynamic solutions. Platform for various real projects. Lack of dynamic models for coupled with other advanced technology. Site buildings, for example, solar energy and energy storage. Another is also important. Uh, it's about managerial perspective. For example, lack of cooperation from the householder caused by the high investment awareness of the technical and low subsidies. Lack of the motivation from the technology service supplier caused by weak incentive policy, low professional measures, and imperfect market environment, and post-spot policy and measures from governments lack of the effective and sensitive mechanism for different stakeholders. Technical research is a resource for promoting the application, thus requires set of well-established and stable methodology for the series of the simulation. In practical terms, a large-scale application requires an effective pathway to identify the barriers, driving faults, and appropriate actions. That's all. Thank you.